Hello, welcome to another video by Help You Excel. Today I'm going to introduce you to SQL, which is an acronym for Structured Query Language. Generally we just pronounce SQL instead of spelling it out. If you've been using Access for a while, you know that you can do quite a lot in Access without understanding even a lick of SQL. But as you progress, you're going to eventually find that you're limiting yourself by not knowing SQL. Certainly if you want to upgrade to MySQL as your backend, or SQL Server, or SQLite, or Oracle, something along those lines. Yes, there are interfaces for all of those database engines, but a lot of the more powerful tools in those more dedicated database programs, you're going to have to use SQL. And even within Microsoft Access, you're limiting yourself to a great degree on what you can do if you don't know any SQL at all. So I'm just going to give you a quick primer. To begin with, I'm going to be writing SQL statements using this table, this customer table. So I just want to familiarize you with the fields on that table. Last name, first name, street 1, street 2, city, state, zip. Pretty straightforward, easy to remember. So as we write out our SQL statements, and let's just take a quick scan of the data set. There's 1,006 rows, variety of states, etc., etc., etc. So that gives you an idea of what the data set looks like and how the table's laid out. So let's just write a little bit of SQL to begin with. Okay, every SQL statement, if it's a select query, I should say, there's different kinds of SQL statements. For now, I'm focusing on select statements where you're selecting data that's already there. Okay, it always begins with select, and then you tell it what fields you want to see. So first name, Access is not case sensitive. Some database languages are. Now you'll notice I'm typing in Notepad++. Notepad++, you can tell it what language you're working in. And I've told it that I'm working in SQL. And you'll see how select is blue and this is black. State is actually a keyword in some database languages. So it's blue, and that's why I put that one inside of square brackets, so that I'm telling the database engine I'm not referring to the keyword, I'm referring to a field name. That's the way square brackets are used in Microsoft Access. Some other languages, they'll use a single quote for that purpose or other things, but Access, it's a square bracket. Okay, so once you've typed out the field names that you want, you'll type from, and then you'll tell it what table you want to retrieve your data from. Traditionally, SQL statements end in a semicolon. In Microsoft Access, it's optional. I usually put it there out of habit. Okay, so let's just put this into Microsoft Access and actually run it against this table. Instead of using the interface, I'm just going to paste it in here. So now you can see why I like typing these in Notepad++. Access does not give you any IntelliSense to help you with the keywords at all, versus Notepad++ does. So now if we put this in Datasheet view, there we go. We've got the first name, last name, street 1, city, state, zip. If you'll recall, the table does have another field that I left out. Street 2, I left it out. Okay, because my query, I didn't want to see street 2. Okay, so that's the most basic SQL statement. And if we put this in design view, you'll see this looks very familiar. Okay, so really what Access is doing is it's writing SQL for you. So if I tell it I want to sort by the city, and you look in SQL view, it adds an order by clause, which I'm going to cover in more detail. So the interface in Access, all it's really doing is writing SQL for you anyway. What it's executing is actually SQL in the background. Okay, so learning the SQL yourself, you're learning some of the secrets under the hood. Okay, so here's our simple SQL statement. Another thing you can do is you can do select star from customer. Okay, and that will just give you every field that's in the table. There you go, every field. If a field is dropped or added, that select star, you'll always get every field. Okay, now I want to introduce you to the concept of an alias. So if I wanted to, for example, okay, you can give every, oops, oh good grief, every field an alias. You can give even table names, you can give them aliases. So I'm saying select from table, or from customer is my table, but I'm giving it an alias of T. I'm going to change this to C because that makes more sense. If you're going to use aliases, it makes sense that you use something that harkens back to the original table name. So now instead of saying customer dot, I can just do C dot. Okay, for this query, the C dot is not required. As we look at other queries, there will be times when you have to preface the field name with the table name. And if you've got long table names, aliases can save you a lot of typing. Okay. The other thing I've done is I want my query, I want it to display first name with a space. I want to display last name with a space. Even though the field name on the table has no space, I can display it in my query with a space in there. Okay, so now when I run the query, first space name, last space name. If we go to design view, because I gave my table an alias, you'll see access renames the table C, and even down here where you normally choose your table name, it's now called C because I've given it an alias. And in access, the way you do an alias is, let's say you wanted to say city name colon city. Okay, you can do that, and maybe you've done this before where you give it a different name. If you look at the SQL, select c.city as city name. So you've given it an alias. So now you can run this, instead of that field being city, it's city name. Okay, so you can use aliases. The next thing about writing your SQL is you can add orders, you can add criteria. So for example, I'm just going to do select star from customer, order by state, comma, let me put this in brackets because that is a reserved word, last name, comma, first name. Okay, so I'm going to select all the fields from my customer table. I want to order by the state first, and then the last name, and then the first name. Okay, so I'll go in here, we'll run this. All right, so it's ordering by state first. All of my A states are first, and then California. And then if I look at just Alabama, oops, that's not what I wanted to do. Now you'll see we're ordered by, interesting, didn't order by last name. Oh, it's because I clicked that stinking sort button. Let's try this again. I'm going to start over because I clicked the sort button, so it's overriding my SQL statement, which is really annoying. There we go. Now don't click sort. Okay, so if you look within Alabama, sorted by last name secondarily, and then by first name. And if I were to put in another like that, you'll see last name primarily, secondary sort by first name. So Abel comes before Glendon. even though this primary key is quite a bit larger. So, okay. You can also put in criteria. So you can say select star from customer where state equals IA. Okay, so that's going to only return results where the state equals IA. Okay, so there's all my Iowa rows. You can add order by as well. Into this statement. So now if we add this in here, we're still getting our Iowa folks, but now we're sorted by last name and then by first name. So you can combine your where clause and your order by clause. Okay. You can also do, let's do state, stinking reserved word, state, city from customer group by state, city. I need that. Okay, so now what a group by does is it's going to look for duplicate rows where the combination of the state and the city are the same, and then it will return just one row instead of that over and over again. To compare contrast, let's just do this. So let's first run it this way. Okay, so you'll see these rows are identical to each other. Birmingham, Alabama, it appears however many times that is. Looks like 8 times. When I do my group by, those 8 rows will become one row. Okay, so let's see what that looks like. Okay, so now you'll see all those duplicates are gone. I've got Birmingham, Alabama, just one time. Okay, so all of those repeats are gone. So this is a distinct list of every city and state in my customer table. Okay, now, if you want to see how many we can add a count. And this is just going to count the number of rows. Oops, we got to put a comma here. That's not going to work. This is going to be how many rows are we eliminating, essentially. How many rows appear. So if we go like this, we can say we've got 8 customers from Birmingham, Alabama. We've got 10 customers from Montgomery, Alabama, etc., etc. If you want to know, okay, what city and state do we have the most customers from? You can sort. Oh, we've got the most from Washington, D.C., followed by Dallas, Texas. Okay. Now, to do what I just did, that sort, you would have to do order by the count of star, like this. Okay, so and we're going to say descending. Okay, if you leave off, you can type in ascending if you want. That's the default. So I didn't have to type state ascending, city ascending. You could type that out if you want to, but it's the default. It just goes without saying. And then if you want to do descending, then you type that out. That's what's traditional. It's just easier. Okay, so if there are any repeat numbers, like here, Los Angeles and New York are a tie, then it's going to sort by state alphabetically. Okay, if there's any other ties, you'll see that again. Okay. Then there is also what is called the having clause, which is a little harder to wrap your head around. I'm going to split these out. At some point, it gets easier to read your SQL statements if you tab by clause, which is what I'm going to do here. The longer your SQL statements get, the more reason there is for doing this. Okay, so what this is going to do now is it's only going to show me city and states where we have more than 5 customers in that city and state. Okay, so the having clause, it does the group by first, and then it does the count, and then it adds a criteria. Okay. Okay, so now if we scroll down here, the shortest one is 6, so every single one of these has at least 6 customers. Okay. Now in design view, this doesn't look like much special. It just looks like a regular criteria, but this is different than a where clause criteria. Okay, for example, if I wanted to say where city equals or state equals California, you can put it under your group by like that. You really shouldn't, because that belongs in your where clause, not in your group by. So what I usually do is I'll drag down state again, and then I'll put it in there like that. I'm not sure, honestly, what access does. Let's take a look to the SQL when you do it that way. Yeah, see, it puts it in your having. So it's going to do the group first, and then it's going to show you the states that are California, versus, this is getting a little into the weeds here, but if you do it this way, it puts it in the where clause where it belongs. See, now it's where state equals California instead of having state California. Now, depending on your table, if you've got a very, very large table, that little change could make a really big performance difference. Oftentimes it won't, and you're going to get the same results either way, but it can be a big performance difference. Now, as you've seen, not all of these clauses are required. Basically, for a select statement, the only 2 clauses that are required are your select statement and your from statement. Your where, group by, having, order, those are optional, but the order is important. You always have to keep them in the same order. Select clause is first, from clause, then the where clause, then the group by, then the having, then the order by. And I asked my wife for help coming up with a clever acronym for this, and she came up with Sigmund Freud would give his opinion. So select clause, from clause, where clause, group by clause, having clause, and then order by. Oops, if I could type. Okay, so that's the order your clauses have to be in, and Sigmund Freud would give his opinion. Select, from, where, group, having, order. Okay. Now, let's show you, I'm going to show you how to do a join. So, the way you join 2 tables is with a join by clause, and I'm just going to show you this other table, so I'm going to use it in a join. Okay, so we got an order table. This is my foreign key. It references back to my customer table. We got order date, ship address, etc. For now, I'm just going to use these two fields, customer ID and order date. Okay, so let's write a SQL statement. It starts out the same way. Start with your select clause. I'm going to do c dot first name, comma, c dot last name, comma, order dot order, order date from customer as C, just C, inner join, order as O. So I'm giving my two tables aliases. And you'll see order, as we know, is a keyword. So I'm going to do this to make sure that it knows I'm talking about a table and not referring to the keyword. On c.id equals o.customer ID. Okay, so this looks complicated, but if you think about this logically, it makes a lot of sense. So we want the first name from the customer table. We want the last name from the customer table. We want the order date from the order table. Okay, so these are my fields. I'm telling it what fields I want from what tables. Okay, my two tables, my customer table, I'm just giving it an alias to make my life a little easier. Inner join, so we're going to join the two tables together. Here's my second table, so we're joining customer to order. To these two tables are going to be joined together. Well, how do they join? The ID field from my customer field equals the customer ID field from my orders table. Okay, so if you break it down logically, these inner joins make a lot of sense. So let's try this out. Ta-da! Apparently I don't have very many orders in here. I thought I had more than that. No, I don't. Okay? So you'll notice couple things. One, my customer table has 1,007 rows in it. This table only has 7 rows in it, and that's because my order table only has 7 rows. Okay, and I'm telling it return results where the ID from the customer table equals the ID from the customer ID, or the customer ID from the orders table. There's only 7 times when that is true, so you only get 7 results. And let's look at what this looks like in design view. Okay, again, I aliased my tables, so you get just C and O for your table names up here. But this looks very familiar. Access drew the join for us. Okay, if you've written queries in Access before, this should look very familiar. And I'm just going to show you real quick. Access will write the SQL for you, but it writes it ugly, and I'll show you what I mean by that. So if you were to write this query this way, you're going to get exactly the same results. Same 7 rows, same fields. But look at what Access does. Oh, that's actually pretty clean. Access used to do a bunch of weird parentheses, and now where it still wills if you do where clauses. Okay, Access did not alias anything. I'll copy this back into Notepad so it's easier to see. It did put the square bracket. Access recognized that that is a keyword, so it put the square bracket on there. It did not alias the tables, so instead of c.lastname, it's customer.lastname, customer.firstname, order.orderDate, and then on your join, so table name, inner join, second table name on customer.id equals order.customerID. So it came to the exact same thing, except for it didn't do the aliases. And when I'm writing in Access, I usually don't alias my tables, but when you get into like a SQL server and you're writing a lot of these queries, especially if you're joining 3, 4, 5, 6 tables, it gets really cumbersome typing the table names fold out over and over again on your inner joins and your field names and stuff. So it gets to where it makes sense to alias your tables with something short that makes sense. When it's just 2 tables like that, C for customer, O for orders, makes total sense. Makes it just so much easier to write out your SQL. Okay. Now, you can also do outer joins. Outer joins get a little bit more complicated, so I'm going to say select C dot first name, comma, C dot last name, comma, O dot order. I'm going to start the same. From customer as C, left outer join, order as O, on C.ID equals O dot customer ID. Now you saw on this one I did an inner join and we only got 7 rows result because it's only going to show me rows where these are equal. When you do a left outer join like this, whatever table appears to the left of the word left. Now I put this on a second line so it looks like it's below, but if you look at this, the table customer is physically to the left of the word left. Okay, so what this is telling us, show me all the rows from customer because it's to the left, and on the order table, show me all the rows where there's a matching value. Okay, so in this case, I'm going to get every row from the customer table. Okay, so if I put this in here, oops, I don't want that, I want to go here. Now you'll see I've got all 1007 rows, and then if they have an order, you've got an order date. If there's not an order, it's blank. Okay, so go like this. Here's my 7 rows that we saw from the inner join, all the ones with a value, and then all of my other rows are showing up. Okay, you can use these outer joins in a number of ways. One of the ways that you could do this, that you could use this, is I could say where O dot customer ID is null. And what that's going to do now is that's going to show me what customers have never placed an order. Okay, so it's going to show me all the customers. It's going to attempt to join to the order table, and if the customer ID field is null, it's going to show those results. So now we only got 1,000 rows. Those 7 rows where the customer placed an order have been excluded. Okay. So that's a left outer join. Now you can also do a right outer join. They end up being the same thing. I basically never, when I'm typing queries, use a right outer join because they're exactly the same thing. It just flips the order around. So if I do this, you can do this if you want, but now it's just telling me it's going to show me every record from the customer table, because now you're looking to the right. So show me every record from the customer table, and then if there's a match, show me the order table. So if I run this, I'm going to get the exact same result. I'm not entirely sure if anybody knows why there's a difference between why they even created left outer join versus right outer join. It makes no sense to me, because by just flipping the order of your tables around in your clause, you get the exact same results. So I'm not, maybe somebody explain to me why there's a left outer join and a right outer join. They do exactly the same thing. So it's a little weird. Okay. You can also do things like there are several aggregate functions like average. I don't remember the. Okay, let's do this. Average this from order detail. Okay, no group by. I'm just going to take all the rows in the order detail and I'm going to get the average price. So if I paste this in here, what do I do? Select average price from order detail. Okay, what did I do? Average price, order detail. It's supposed to do wrong. Interesting. Query 1.order date. What the heck? There. I don't know what I did wrong, but maybe you spotted something I didn't. So this is just saying take the average of the price from all the rows in the order detail table. And then you can also do min, you can do max. Select again. There you go. So for the whole table, here's the average price, here's the min price, here's the max price. Okay, you can also actually change the structure of your database using SQL. I'm going to delete these. For example, here I'm going to create a whole table using a SQL statement. So the syntax is just create table, give it a name, begin parentheses, and then you start defining your fields. So my first field is going to be ID. I want it to be auto increment. I'm going to add a constraint to it. The name of the constraint is primary key. You can name the constraint whatever the heck you want. And then keyword primary key. Okay, so that's going to make this an auto number with it being the primary key. Okay. Then first name, it's going to be a text field, 100 characters long. Not null is going to make it required. Okay. I'm going to add a couple in here, like, this is bad design, but this is the first thing that comes to mind. Okay, birth date, etc. Okay, so it's just a matter of knowing your different data types. So you can copy that into a regular SQL like this. Now you can't put this in design view, I don't think. Yeah, it won't let you. But you can execute it. And I'm going to delete this table really fast. Execute this. Now you'll see I've got a brand new table, and if we open this up, ID is an auto number, first name, last name. These are all required. If you look down here, required yes. Age is long integer. And I did not say not null, so it is not required. Birth date is date time, also not required. Okay. You can also alter tables. For example, I defined first name as 100 characters long. Let's say I changed my mind and I want that to be 150 characters long. So the syntax for this, you say alter table, you give it the table name. Oh, this is actually the wrong syntax, sorry. Tell it alter table, table name, and then you say I want to alter a column. You give it the name of the column you want to alter, and then you redefine that table. Now, for example, if I want to make it not required, I can do that. And now it'll be 150 characters long, and instead of 100, and it will not be required. So let's take a look. First name field, 150 characters long. Oh, interesting. Did not change the required part though. Should have. I'm not sure why it didn't. It didn't throw an error either, so it recognized the syntax. Interesting. Wonder, do I need to refresh? Doesn't seem to be it. Interesting. I'm not sure why I didn't do that. That should have made that not required, but it didn't. You can also add columns. So you go alter table. You give it a table name. I forgot the table name here. So you alter table, you tell it what table you want to alter. I want to add a column called email address, and then I'm going to define it as 255, not null. So again, you can just execute this. And now if we go in here, there's a new field called email address 255, and it is required. You can also drop columns. Okay, so here I want to alter the same table. I want to drop that column that I just added. I changed my mind, I don't want it. Boom. You have to be careful with these alter table statements. You'll see there is no prompting, like, are you sure? It just happens, boom, and that field is gone. So if you had data in that field, that data is gone forever, and you're not getting it back. So you do have to be careful with your alter table statements. Okay, you can also do insert statements. So into my new table that I just created, the syntax is insert into, and then you give it a table name. And then inside of parentheses, you give it the fields that you're going to insert your values into. And then you say values, begin parentheses, and then you just make sure you line up. So this first one is going in the first name, comma, second one goes to last name, comma, third one goes to street 1, putting an empty set in street 2, city is going into city, state, you get the idea. Okay, so just make sure as you're writing these that you line up what's going to what. And we can run this. Open it up. Now we've got one row of data in our table that wasn't there before. You can also insert from one table to another. So this one, the syntax starts the same. Insert into, person name, tell it all the fields I want to go into. But instead of doing values, now I'm doing a select statement. So select, same fields, first name, last name, yada yada. But I'm going to select it from my customer tables. So right now my person table just has one row. My customer table, as you'll recall, has 1,007 rows, I think. So when I run this, oh, and I put a where clause in here. So I want to insert all the rows where their state is Iowa. I'm going to run this. And just like that, now my person 1 table has all the rows from the customer table where the state was Iowa. Now if I want to get the rest, I could say where it's not Iowa, and that's going to insert the rest of the table. Now if I open this, there should be 1,000 some rows, 1,008 I think. Okay. You can also, using SQL syntax, you can create indexes. The syntax is just create index, give it an index name. That can be anything you want it to be. And then the keyword on, you tell it a table name. And then inside parentheses, you tell it the field or fields where you want your index to go. So here we go. Let's run this real quick. Oh, I've got it open. You can't alter in a table when you've got it open. Let's try again. Okay, so now if we look in here, on the indexes, we have a new index. And what did I name it? First name IX. Sure enough, first name IX. On person 1, field name. So person 1 is my table. Field name is first name. So we got an index on there. Now, before I run this one, because this one is going to fail, I think. Let's try it. It should fail, because I know my name's in there at least twice. Okay, now I want to create a unique index. All you have to do is add the keyword unique. So create unique index. Has to be a different name than this one. You can't have two indexes with the same name. On table name and then first name. Let's do this instead of last name. I think that one will actually probably run. No problem. Nope. So there's at least two rows where the first and the last name are the same. But if we add city, state, zip. There we go. So now if we look at this table, look at the indexes again, we've got a new index called fname.ix unique. Here it is. And then here's the fields. I told it. First name, last name, city, state, zip. Okay. And if you look up here, I tell it, yes, I do want that to be unique. You can also do alter table, person one, drop index. Okay, so as you can probably guess, that's just going to delete that index that I just created. So if I close this, run it, maybe it's just drop. Alter table, maybe it's just drop index. Huh, I don't know. Getting my syntax wrong somewhere. Alter table, person one, drop index. Might be drop index from person one. I don't think that's right. It's been a while since I've done this apparently. Alter table, drop index. I'm not sure why that's not working. I thought that was the syntax, so I have to look into that a little more. You can also do delete statements. So delete star from person one where state equals IA. So that's going to delete all the rows from that table where the state equals IA. So run it. Person one now, if we look in here, IA, if there were any, should it be between Hawaii and Idaho? There's none in there now. Nothing in there for Iowa. We can confirm for sure. Just write a quick statement. Nothing there. Okay. All right. So there's a quick primer into SQL syntax. Ended up being 43 minutes, so I guess not so quick. But a lot you can do with SQL. As you progress into your code, you're definitely at some point going to have to write some SQL. Definitely if you want to advance to SQL Server, those sorts of things, you're going to have to get into writing SQL statements versus using the interface. If you have any questions, you can reach me on my email, paul@huxl.com. Find me on my website, huxl.com. If you enjoyed this video, be sure to give it a like. And if you'd like to see more like this, be sure to subscribe to my channel. Thank you.